All right, in a previous video, we were talking about limits, and now we're going to talk about just simply one-sided limits. So what we were talking about before was that we wanted to know, let's say, as our x's were approaching a number from both sides of that number, what were the y values going towards, right? So if we followed the function, what does it appear as though the y values are doing as your x's get close to some number? So for example, the limit as x approaches 1 for this function that we have graphed here is 2, because as our x's get closer to 1, the y values get closer to 2. The idea of a one-sided limit is I can break this down into what happens as the x's approach 1 from the left. What is that limit? So what does it look like my y values are going towards if I just look at from the left side? And then also I can look at this as just from the right side. So as my x's approach 1 from the right, what does it appear as though my y values are going towards? Now in this example, it's still 2. As I approach 1 from the left of 1, my graph is going to 2. As I approach x from the right of 1, again the y values are going to 2. But in some cases that it's not going to match up. Okay. So we need to understand what this idea is of left side and right side limits. So this says that the limit of a function as x approaches a is equal to L if and only if, which means that this has to happen, if and only if, the limit as you approach x from the left, which is what that little minus means, from the left, and the limit as you approach the a value from the right. Okay, so this means left, this means right, are also equal to L. So what that means is I have to approach the same thing from the left and from the right in order for the general limit as I approach that thing to exist, and they will be the same answer, right? So my left-hand limit here, the limit as the x's approach 1 from the left is going to be 2, because it's going towards a y value of 2. The limit as x approaches a from the right, so as x approaches 1 from the right, is also 2. And therefore, because both of those exist and they both equal 2, the limit as x approaches 1 is also equal to 2. So we take both left and right into consideration. Okay, so let's answer some of these. You'll catch on, I think, pretty quickly here. So the limit as x approaches 2 from the left. So we're looking at 2 from the left of 2. So the way I do this is I go to the left of 2, I go onto the function, and I follow that back to an x value of 2. And I say, what does it look like the y values will be doing as my x values get closer and closer to 2 from the left in this case? And the answer is 3. Right, my y value, if I'm left of 2 and I'm following my graph, it looks like my y value when I get to 2 should be 3. Let me go down from here. What is the limit as x approaches 2 from the right? So again, go to 2, go right of 2 and go into the function, and go back towards 2 from the right side of 2. As my x's get closer to 2 from the right, the y values are actually going down here to 1. It looks as though my y value should be 1. And therefore, part C here, what is the limit as x approaches 2? Because my left and right hand limits give me different values, the left hand limit is 3, the right hand limit is 1. Because those are different, this limit does not exist. Okay, because that says in general, what are your y values doing as you get close to 2? Well, they're doing different things from the left and from the right. Okay, from the left they're going to 3, from the right they're going to 1. So in general, what are they doing? I can't say, right? That limit does not exist. The left and right hand limits do exist, but they're not the same. Okay, same thing, but we're looking at 5 here. Limit as x approaches 5. So as we approach 5 from the left, so go to the left of 5 and follow that to 5. That y value that we are approaching is 2. Approach 5 from the right, so go to 5, again go to the right of 5, go to the function, follow that back towards 5, and again the limit there is 2. So the third question here, what is the limit in general if we approach 5? And the answer is 2, because these two things are the same. Okay, next up is infinite limits. I just have an equation graphed here. This is the equation y equals 1 over x squared. And the question is, what is the limit as x approaches 0 of this function? What is the limit as x approaches 0? Well, as my x's get really close to 0 from the left side of 0, okay, so if I'm going in this way, the y values are getting increasingly larger, right? They're going way up as I get closer and closer to 0. And the same thing is happening from the right. From the right, as we approach 0 from the right, again, the y values are going way up towards positive infinity. So, in this table, this is saying for both positive and negative 1, this function will give me 1. For both positive and negative 0.5, and so forth. So for both positive and negative 1/100th, we get we get a y value of 10,000. So the question is, as I get closer to 0, and this is looking at from the left and right at the same time, but I'm getting closer to 0, it's becoming a smaller decimal. What are the y values doing? And if you follow this pattern, those y values are getting really big, which means the limit as x approaches 0 of 1 over x squared is actually going to equal infinity, because it's going to keep on getting larger and larger and larger. As I get closer to 0, my y value will become increasingly larger, and therefore the limit would be positive infinity. They're going towards a number towards positive infinity.